Hey everyone, welcome to Understanding Equivalent Ratios. If you're in my class, this will be a great review before your concept check tomorrow. If you're just here to get a quick refresher or need some help with equivalent ratios, you're in the right spot. So let's get started. So before we can even discuss equivalent ratios, we have to understand what a ratio is and what it's representing. So I gave this example as what is the ratio of circles to stars. And remember, whether you're in my class or you're in someone else's class, the teacher probably talked about that the order matters. And if it's given to you in a problem, you have to write it in the order that was given to you. So for example, the ratio of circles to stars is 5 circles to 3 stars. And you can write it in this form. You can write it with the word 2, 5, 2, 3. Or you could write it as a fraction of 5 over 3 in fraction form. It's not a fraction because it's not a part to whole, but you can use a fraction symbol to represent a ratio. So remember, there are 2 types of ratio types. There is part to part, which this one is. We were looking at circles to stars. And then there could be like part to whole if you did boys to students. Now let's take a look at what equivalent ratios mean. So in this problem, it says, using the pattern above, if there were 15 stars, how many circles would there be? So in this type of problem, you don't necessarily have to write the order correct because you're just trying to solve the problem. But you always start with writing a ratio. So in this pattern, the ratio is for every 3 stars, I'm going to put an S for stars, there is 5 circles. And I'm going to put a C for circles. And I highly recommend labeling your ratios, whether it's just one letter or writing the whole word out. So it is saying, well, what if there were 15 stars? So that would need to fall underneath the 15 stars. Labels need to line up. Stars and stars need to go in the same spot. This is when the order does matter once again. So then you have your new ratio that you're trying to get to. And this is your I don't know. So we're trying to find, what if there are 15 stars, how many circles would there be? And this pattern would need to be the same. So what you would see is that 3 times 5 will give me 15. So you should be thinking 5 times 5 gives me 25. So I would have 25 circles in this problem. And what you could think is, if I wrote this line again, that would be 6 stars. And some of you might be thinking, oh, I could make this a table. You would have 3 and 5. And then if I copied it again, I would have 6 and 10. And so on and so on. 9, 15, until you got to 15 stars, which would give you that 15 to 25 on the bottom. And a table works great when you are looking at smaller numbers, like trying to get to 15. But sometimes it doesn't make as much sense to count all the way to that number. For example, like the next problem. Okay, we are still looking at the same pattern in this problem, but I've just changed what we're looking for. This time we're looking, what if we had 60 circles? How many stars would there be? So you're still going to write this ratio of, oh, I have 3 stars to 5 circles. And some of you that are making your tables, because I have several students in my class making tables, you have your stars and your circles, and you can still make your tables. That's completely fine. It still would be 3 to 5. But are you going to want to count all the way, because then you'd have to go 10, 15, 20, 20. Would you want to make a table that goes all the way to 60? No. And that's where using your table to get to the multiplication would be great. So you could just go from this one and saying, okay, I have 60 circles. So I need to figure out 5 times what gives me 60. And if you don't know, go on to the side and divide it. So 5 into 60, some of you might think 5 times 10, which gives me 50. You have 10 left over, and that would be 5 times 2. Oh, so it's 12. So if I multiply 5 times 12, Remember our golden rule with ratios, what you do to one side, you have to do the other. This would be times 12, which will give you 36 stars. I do want to show you in the table, you could have continued and said 06 to 10, and then wrote your 60 down here, and then you could have multiplied from the 10, because 6 to 10 is equivalent to 3 to 5. So that would be times 6 here. So I would also need to do 6 times 6, which gives me 36. So you can also use this method as well to get to your equivalent ratio. Okay, comparing ratios. If you're in my class on your concept check, you're going to have to determine if two ratios are equivalent. So in this picture, if we did boys to girls, I forgot to write that. So if we're looking at boys to girls, I want to know if these two are equivalent. So in this first one, we could say we have 1, 2 boys. So we have 2 boys, and I'm going to put 2B, 2, 1, 2, 3 girls. And then if we look at this next one, we have 1, 2, 3, 4 boys to 1, 2, 3, 4 girls. So you might have to, if you're in my class, you always have to explain why or why not. So you should notice, well, if I have 2 boys to get to 4 boys, I'd multiply that by 2. So from 3 girls to 4 girls, you're multiplying that by 2. That does not come out. That makes 6 girls. So they're not equivalent, because 4 boys to 4 girls is not equivalent to 2 boys to 3 girls. Or you could do it the other way. You would need 2 boys to 2 girls to be equivalent for 4 boys to 4 girls. Either way works. Just make sure you're explaining why or why not a ratio is equivalent or not. So these ratios are not equivalent. They do not go together. Okay, now let's look at a few word problems. So remember, when you're reading word problems, we underline, highlight important things. So the ratio of girls to boys, so first off, that tells you the ratio. In a chess club is 5 to 4, so that's other important thing. There are 32 boys. How many girls were in the chess club? So in my class, I always tell them, write the original ratio with labels. So for the original ratio, you would have 5 girls to 4 boys. And then I would look, what do I know about the new ratio? Well, in my new ratio, I have 32 boys. So I'm going to write my 32 boys. Once again, these labels have to line up, because they're talking about boys over here, so the boys need to be on the right on this side. Then you need to look, how do I get from 4 to 32? Times 8. So on this side, I can also have 5 times 8. Okay, and you should know 5 times 8 is 40. So we would say, oh, I have 40 girls in the chess club. Okay, let's do another example of the word problem. Okay, in this problem it says a classroom had 35 glue sticks. That's probably important. If the ratio of glue sticks to glue bottles was 5 to 2, how many glue bottles did the classroom have? Okay, so we're talking about glue sticks versus glue bottles. So write your original ratio. So 5, and these are glue sticks, so I'm going to put an S again. 2 glue bottles, and right here is where I'm finding, I'm going to color it again, the order, how I know that the 5 is sticks and the 2 is going to be bottles. So we have 2 bottles here. And they gave us 35 glue sticks. So we know that is in our new ratio, should be underneath the other glue sticks. So once again, we're looking, how did I go from 5 sticks? What am I scaling up by? Well, if I multiply this by 7, that gives me the 35. So my golden rule for ratios, what I do to one side of the ratio, I must do to the other. So we're going to multiply this by 7 as well. And 2 times 7 gives me 14. So I have 14 bottles of glue. Okay, I want you to pause the video, and I want you to try to solve this problem on your own. I'm going to read it, and while I'm reading it to you, I would write down those important things, like write down your original ratio. So a recipe called for the ratio of sugar to flour to be 10 to 3. If you use 70 ounces of sugar, How many ounces of flour would you need to use? Okay, welcome back. Hopefully you paused the video and tried this one on your own. So if you had a piece of paper, you could underline sugar to flour, that's important, 10 to 3, and you're using 70 ounces of sugar. How many ounces of flour? So my original ratio would be 10 sugar, because sugar came first here in that ratio, to 3 flour. Okay, didn't mean to write out the word. They gave us 70 ounces of sugar. And then, so we're trying to figure out what is the flour. So you should see here, 10 times 7 gives us that 70. So I need to do 3 times 7, which gives me the 21 ounces of flour. Great job, everyone. I hope this video really helped you kind of get a better understanding of equivalent ratios. A few things to remember. One, when we're creating equivalent ratios or fractions, we're only multiplying and dividing. We are not adding and subtracting, because we have attempted that, and that does not create equivalent ratios every time. So just remember, you are multiplying and dividing. And don't forget, set up that original ratio when you are solving a ratio problem. If you have any other questions, feel free to leave them in the comments, and I'll be more than happy to answer them. Have a great night.